Hi, good morning. This is the last session of our 4-day course on digital demography. So thank you for making it this far. And today we are gonna speak about computational approaches in demography. And so we have actually also other things happening today. So as usual, just want to check with you if there are any urgent questions about the past days, sorry. And then we're gonna dive right into so the topic, like the largest topic in computational demography at the moment, which is demographic simulation. And so I would like us to follow a similar structure to the one that we had yesterday, where we have a short introduction to the subject. It's going to be shorter than yesterday. And then we focus on 2 examples. So the 2 readings for this week. And then, so which is a paper on the HIV/AIDS epidemic in Zimbabwe and the effects that had on kinship availability. And another one is about the projection of kinless adults in the US. So then we are going to have a discussion similar to yesterday, and then there's going to be some course admin at the end. So you've also done this for other courses, I think. So let's get started with the questions. So remember, you can, and I am also going to split my screen. You can just send a message in the chat or interrupt me if you want to say something. So are there any questions about the topics that we've covered the last days, or about the assignment or something else?
I have one question. On Tuesdays, you haven't finished the slides. Thank you.
Yes. Yeah. So if we have time, so my plan is to finish a bit earlier today so that we can have a discussion. So I could mention something about that if we have time. Yeah, I'll do my best.
Thank you.
Yeah. Something else?
I have a question about the assignment for the exercise 2, just to be sure. When you mentioned the 2 readings, which reading are you referring to? The one about longevity?
So in the assignment, it says in the exercise. Exercise 2.
Okay, sorry, because I don't have this version with the edition. Okay.
Sorry. Okay. Anything else? Okay, you can also, we're going to have a time at the end of the course. If you want to bring something else, if you want to bring up something else. So what I want to talk to you about today is demographic microsimulation. And so has anyone come in contact with or has experience with demographic microsimulation? So if anyone has, could you just like write it in the chat, like yes, and like a couple of words, like what you have done or like what you know about it. And in the meantime, I'm just gonna give you a short introduction to what microsimulation is. So basically what we are interested in when we think of demographic microsimulation is to model individual level behavior. Okay, great. So you had the agent-based modeling course. Okay, great. So what we are gonna speak about today is, so the principle is similar to agent-based modeling, but it is, but in the implementation and the type of analysis that you can do is different. So in ABM, so you are modeling individual, so agent-based modeling, you model this individual, you have these agents in a model that you then assign some rules of behavior, and then they act according to this, and then you can like analyze some outcomes that you're interested in. So demographic microsimulation, the one that I will be discussing, is similar, but it's a bit more restricted in the sense that you don't, like, we are not so interested in these social behaviors, but we are mainly looking at the demographic components of population change. And so what this means is that we have, in the end, so we have made up data, and that we produce, so we invent data in a way, like the data that we use when that we receive from a microsimulation is not data from the real world, but when we do demographic microsimulation, the inputs that we use do come from the real world, and in the readings, there are different examples of what this real world input data looks like. And also how sometimes we can also kind of match this data, that the outputs from our microsimulations to reality. Yeah, and I'm gonna, so she's mentioning this transition probabilities, and so we're gonna speak about this a bit when we look at the examples. Actually, what the different ways in which we can conduct demographic microsimulation. So the one that we will be focusing on, so the two readings we're using this method, is SOCSIM, but there are other alternatives like CAMSIM. So you probably use NetLogo for the agent-based modeling. In many cases, you can also do these kind of things. You could implement them in practice in R or Python if you have the patience. But maybe it's not the most efficient way of doing it, since this has a long tradition, and there are already implementations. So I would like to speak briefly about SOCSIM, which is a classic demographic microsimulation software that has kind of a long pedigree in demography, and is very linked to UC Berkeley, where it was developed. So basically, it is stochastic microsimulation platform written in C in the 1970s, and the way it works is that you start with an initial population, and then you apply age-specific rates. So you say, given this initial population, there are like 1,000 people initially, and then these people are going to get married, they're gonna die, and they're gonna have children, and their children are gonna get married, they're gonna die, and they're gonna have children. And the probability that any given agent in this model experiences one of these events is determined by a set of age-specific rates, right? So these can be death rates, or they can be fertility rates, or they can be marriage rates, so some estimate of the probability that marriage would occur at a certain age, or there could be other kinds of transition rates, right? So you can have these rates, for example, for migration. So like, what is the age-specific migration rates from like one state to another state? And state, I mean, not as in the geographic connotation, but the like the state of being a migrant and non-migrant, and then you transition to the state of being a migrant. So it's quite flexible, but it only, in principle and in practice, relies on an initial population and a set of rates and transition probabilities. So once you have this, and we're gonna, like, maybe, I don't know if this sounds a bit abstract now, but I hope that as we discuss the examples, it's gonna become clear what we mean by this. And the important point is that, so this was hosted at UC Berkeley for a very long time. And now we are in the process of transferring this to the MPIDR. So Carl Mason, who's one of the main authors of this package, he was at the MPIDR a couple of weeks ago and working with Tom Tyler from the Lab of Digital Demography. And the idea is to host it at the institute and also make it easier for people to use. So if this is something that you're interested in, please do get in touch with me or with Tom, and we can arrange something. So the other thing is that it only, at the moment, it only runs in Unix systems. But Tom is working a lot on adapting it for Windows also, so that it's more accessible. So this is what it looks. This is what Microsimulation currently looks like in SOCSIM, where you have. So this is just a command line where so you run everything from there, and then you get some outputs. And so here this is also referencing this file. In this case, it's called test.sup, and this file has all the transition rates and all the demographic rates in it. So in a way, just SOCSIM takes this text file and then runs it, and the number is just a random number, so that you can introduce some randomness in the model, in the simulation, and then in the end you get something like this. So this is also in the assignment folder, and it also applies to Sweden. So this is a microsimulation of the whole Swedish population from 1603 in this case to the year 2100. And this is, so I changed a bit the formatting so that it actually looks the same as the FamiLinks data that you're going to be using for the assignment. It has the same structure, but the data come from microsimulation. So the data, in a way, are independent from the genealogies. They refer to the same population and they refer to the same time frame. So this is some of the things that I'm doing now, for example, like comparing how, like the estimate, you can estimate the same quantities with microsimulation, with genealogies, and with other data sources such as register data. So if you remember what I said yesterday, like it's more likely that we get the better estimates when we complement traditional data with online data, or in this case. So this is like, I think that this is like a good example of combining offline data. Say you have register data for Sweden, then you combine it with digital data, which are the online genealogies, and then you combine it with computational data, which is the model, which is the microsimulation. And you can observe like similar things with these three data sources. So this is also in the assignment. If you want, it should be also quite easy just to use the same code that you use to do analysis on the FamiLinks data. and do it with the simulation. So it's not part of the assignment, but it's out there. So now we're going to do the same thing that we did yesterday, where we're going to briefly review the 2 studies that were assigned for today. And then I'm going to ask 2 people to take care of, be in charge of one study, and 2 other people would be in charge of the other study. And then we will review the strengths and weaknesses of the reliance of the studies on microsimulated data, particularly microsimulated data using SOCSIM. So same dynamic as yesterday, different people. So there are 2 studies. There is a study about Zimbabwe, and there's a study about kinlessness. So Alexander and Octavio, can you please be in charge of the Zimbabwe study? And Madalena and she would be in charge of the kinlessness study. It doesn't mean that the others cannot contribute. This is just like so that you guys can give us an introduction into the further discussion. Right. And at some point, maybe after reviewing the studies, we're gonna take the break, and then we're gonna come back for the second part of the lecture. Okay. So are we good? Any questions? Okay. So the first paper that that I asked you to read today was a study on the impact of the HIV/AIDS epidemic on the availability of kinship of relatives in Zimbabwe. Right. So basically, summary of the study, we wanted, or rather, Emily wanted to estimate and project the probabilities of orphanhood and how kinship structure would be affected by the HIV pandemic in Zimbabwe. And the data, so the results come from microsimulations conducted in SOCSIM using rates, demographic rates. So the thing is, so I told you you have the microsimulation, and then, but you need to give it something, right? You need to give it some parameters so that it can define, so it can assign probabilities of events to different actors, or to different agents, to use the language of ABM. So these rates came from the UN World Population Prospect and from Demographic and Health surveys, so DHS, and from different databases such as the World Fertility and Marriage database, and also UN HIV infection rates. Right? So these transition probabilities that she was mentioned, they came from these HIV infection rates, where we can see the rates of infection at different ages, and this you put into the model, and then you get the simulated population. So there are many findings, but 2 findings that I found particularly interesting is an increase in double orphans that have no living grandparents, and I'm gonna show a graph now to make this clearer. And then the other thing that Emilio found was this shift of responsibilities to aunts and uncles as a result of the excess mortality caused by the epidemic. So these are double orphans on the left-hand side. So children under 18 years old who are double orphans, and then also who are double orphans and have no living grandparents. Right. So the whole idea of this study is that the relatives provide support. So like relatives provide support on the one hand, and on the other hand, the absence of relatives is a burden on those that survive. And so here microsimulations allow us to do this. So if you see the x-axis, this is going up to the year 2050. So it is obviously not something that we could just obtain from surveys or register data, because we don't know how these things will look then. So this is another image where now in the x-axis we have the percent of double orphans younger than 10 years who have at least one living sibling older than 15 years, right? So this is children who have a sibling who is older and may provide them with support. So you see this decline up to the year 2010, and then a slight increase, but not quite to the levels before. So one of the reasons why it's so we need microsimulation, and we're gonna see this in the next study, is that these kind of questions that the authors were asking in the readings this week were, so these questions, there are many demographic components that contribute to the change, right? So there is excess mortality at different ages, but then there is also population aging, and there is like the mortality that would have happened anyway in the absence of the epidemic, and the reduction in fertility also causes people to have fewer siblings, and so like it's kind of hard to think of all of those things in isolation, and microsimulation gives us this like framework for observing all these processes happening simultaneously. And this is the last figure that I wanted to mention. So this is actually now in the y-axis, we have the number of living uncles and aunts, and we see how this number recovers. So there was a fall in the 1980s, and then it recovers after 2020. Okay, so this is a very brief summary of the first study. The second study is uses microsimulation to look at a similar phenomenon, but in a very different country and looking at a different subset of the population. So now we're not interested in children anymore, but we're interested in older adults. And to understand how demographic change, and particularly differences between races in the US, will affect. So the outcome now is the older population who doesn't have any living relatives, right? And how this will evolve in the future. So in this case, the rates come from the US Census and Human Fertility Database, and they also use data from official statistics. So this is, I don't know if you had the chance to go and review the supplementary materials. So I'm going to show some graphs from there, but I think the supplementary materials are very good, and you can see actually how much work they put into creating these simulations and making sure that they made sense. Some of the main findings, so they find that there is gonna be an increase in the percentage of adults over 50 years old with no living close family members. And they also document this difference between Black and white non-Hispanics that we're going to see now in a second. And the second thing that they do, that the microsimulation allows them to do, is to take a look at the mechanisms. Like, okay, we know that, or like the microsimulation suggests that this is the pattern that we're going to observe, but what explains these changes, right? So what are the mechanisms behind this? And so they identify three mechanisms: so declines in marriage, the rise of one-child families, and changes in mortality that will affect the Black and white population in a different way. So here in this table, you have the different data sources that they use for the study. So you can see there's this initial population in 1880 that has an age and sex structure, and then they take data from life expectancy, fertility, the proportion who are male at birth, marital status, parity, marriage rates, remarriage rates, divorce rate, and of course divorce and marriage is very important for this, for their particular research question, and partnership rates, and so the other thing that we see here is that not all microsimulations are the same, and sometimes we are interested in including some parameters. So when we say we model the US population, as they did here, that doesn't mean that the resulting microsimulation is the only possible representation of the US population, nor is it supposed to be an accurate twin of the US population, if you will. So they are related in some way, but our microsimulation will always be limited because it's only going to represent the attributes that we chose to include in the simulation. And so here you can see, like, this is the specific attributes. So some are basic and we need them, but depending on our research question, then we would add some or remove some. So one thing that they do that is so microsimulated populations are not real populations. Right? That's very important to keep in mind. But we want them to be as close as possible to real populations, keeping in mind our research questions. So one way of checking this is so we produce the population, we have a population file, we run the microsimulation, and then we observe for the years for which we have data, we can compare some measure that we define, that we estimate by hand from the output file, and we compare that measure to the measure coming from another source. Right? So in this case, they are comparing the output to the input. So the idea, I'm just gonna explain it in another way because I don't know if it was clear. The idea is that you give the simulation rates, basically, and then these rates are gonna be translated into probabilities that the specific agents experience an event. So that an agent gets married, that an agent divorces and then marries again and has a child and dies at a certain age. So that's all the result of a probability distribution that comes from the rates. And then this just runs for hundreds of years in your computer, and then you get the output. But one way of checking that the result of your simulation actually makes sense is to re-estimate those initial rates that you provided to the simulation, but ignoring, not looking at the rates, but only looking at the output. So at the population. And then, so what you want is the rates that you're estimating from the real, so not from the real, so the rates that you're estimated from the simulated population to match the ones that you used as input in the model. I hope that was clear. We can also come back to that if it's not. But what you see here in the image is the red line is the output, and then the circles are inputs for different measures, right? And they match. So they're in some cases they don't match, but it's quite close. So that's encouraging. Here, for example, so mean age at first marriage for non-Hispanic Blacks, there is a drop here in the input data around the 50s that is not so well captured by the simulation, but everything else seems to be okay. Okay, so this is the first part, which is validating our simulation. Right? We need to go to convince ourselves, and in this case also the readership, that our simulation, our model approaches reality in some way. So you will remember this from the paper. If we look at this B and C panels, this is the percent of the population by year who will be kinless. So this is older adults who will not have close living relatives. And the interesting thing is that you see the comparison between the dashed and the solid line. This divergence between the black and the white population. So this being the black population on top and this being the white population. So more kinlessness amongst the black population. And because, again, the input rates for black and white were different. So we would expect them to diverge in a meaningful way. And these graphs, I'm not gonna go into detail, but basically this is showing what drove this change. And so which demographic components actually caused the increase in kinlessness, in the output that we're interested in. And the reason why they could do this is because they had the data. So they had the complete genealogy, which means that they could also have like yearly censuses. Right? So once you have the microsimulation data, you can conduct yearly censuses. And with these yearly censuses, you can compute exposure and whatever it is that you're observing. And you can look at this over time. So it's like it is perfect longitudinal data. In a way, the only drawback is that it's not real. But you can compute this, so you can get to understand or to unpack the mechanisms that drove in your microsimulation the results that you see. And what you normally do is you don't only run one simulation, but you run multiple simulations. And then, so they don't do it here, but you can also show uncertainty around your estimates based on 10, 20 simulations. That are always going to give you different results because it's a stochastic process, but they will be in a certain range. Okay. So that's it from me. So the rest of the session today, so we'll be having a bit more discussion, and but I would say let's take 5 now, and so then we can come back at 12, 11 past 12, and then we'll continue with the discussion. Thanks. Okay. Welcome back, everyone. I hope you managed to stretch a bit. What I would like us to do now is same exercise we did tomorrow, just different people. So the idea yesterday was that we take now, let's say we take 5 minutes again. So so that you have time to think about the strength and the weaknesses of the way that these two studies use microsimulation data. And everyone, please just write your ideas in the chat. And then Alexander, Octavio, Marina, and Chi, you're gonna have some time to share your own perspectives on this. So 5 minutes, it's 12:12, so 12:17, we continue with the discussion. Okay, yeah, so a very good point about how the population follows your ideas, which can be both good and bad. And we can explore this a bit, like what it means, to what degree it follows your ideas, and if it is more than it follows your ideas in other types of research design. So comments about how it's difficult to account for some things such as migration. So like there is a way of accounting for migration, and so I mean I'm not gonna. So you can present your position, Alexander, and then we can discuss this issue with migration. So Hannah asking about what happens if demographic rates change over the course of the predicted period and confidence intervals. So I didn't mention this, but so basically, if we ran a microsimulation and we had fixed rates, that would essentially give us a stable population, which is interesting, but maybe doesn't come close to any actual population that we would be interested in studying empirically. So we expect rates to be time changing. So the rates don't stay the same, but that's why we use, for example, projected rates. So we define how often they change. Like they can change every 5 years. They can change every 10 years. And then these the confidence intervals. So one way of getting confidence intervals is by running multiple simulations, and then from the spread. And I'm going to show something if there is time at the end. You run multiple simulations, then you get some spread of the data, and then you can compute confidence intervals. But we are going to start now with Alexander. And what do you think about the Zimbabwe paper?
First of all, the obvious strengths, advantage, as well as in any other case when microsimulation is used, is that no one has available data on the issue. And what about the weaknesses? The total fertility in Zimbabwe is decreasing, and it started some time ago. So we had to use some projected demographic rates, which may give some kind of uncertainty. And I think that migration also affects demographic rates and consequently may have some effect on kinships. So it should be taken into account. But I guess that in the case of Zimbabwe, it's very difficult to do because of lack of data, first of all. And so consequently, it also increase a degree of uncertainty more concerning the outcomes of simulation, I think.
Yeah. Great, thanks. So indeed the Zimbabwe paper uses projections from the UN World Population Prospect, if I'm not.
Yes.
And it uses specifically the medium projection, right? So like as you are probably aware, the UN WPP projects multiple scenarios. The most commonly reported is the medium one, which is the most plausible one. But until recently, it didn't provide any uncertainty around the estimates. So it's more scenario based. So you have like high, low, constant fertility, and medium fertility. But now this revision, so 2019, there is also probabilistic projections of population and of rates. So this is something that is yet to be implemented, but it's that's good. So Octavio.
Hi everyone, how are you doing? I'm thinking actually that the first day of the course, I told you that one of my main thing I was looking forward to is kind of the lack of sources to do proper demographic research that we have in many countries. This paper does a very good effort to show that you can still answer big questions with very limited data, or at least try to give a reasonable answer to those questions. Because I think that it's very similar what Sasha said, that you get a result from this, but the result that you get is, you think is reasonable, but maybe you don't have the means to prove that the result you got is kind of the right one. It's like showing you an answer among a possible sea of answers. Obviously, you can't help it for the time being because you cannot improve like magically the data. So I believe that these kind of approaches are, as long as we do the right thing, which is acknowledge the limitation, which Emilio does, I think these approaches could give us the potential to answer difficult questions. Because asking about kinship and double orphanhood in Zimbabwe, I don't think it's an easy question, and that he can find a possible answer for that is, I think, a great accomplishment.
Mm-hmm. Great, thanks. So I think there are like some very interesting points in like people wrote in the chat. Does anyone want to add something? Okay, so while we wait for someone to speak out, I can share with you some of the pros and cons that I found in the paper. So as it has been mentioned already, so one pro is that there is no alternative data source. One con is that it's difficult or impossible to compare to ground truth because it simply doesn't exist. Then there's also the issue of the uncertainty. Like the more we go into the future, the more uncertain so like there are two sources of uncertainty. Like there are more, but there are two main sources. The first one is the projections. Right, so if you've seen these probabilistic projections, then you'll remember that the graph, say, like it goes like this into the future, and then like the intervals around the band just become larger and larger the farther we travel into the future, because we're more uncertain about what's going to happen. So this is one source of uncertainty, and the other source of uncertainty is that introduced by the simulation. And so computing and visualizing that is a challenge. So I mentioned one approach, which was to run multiple simulations, also run multiple simulations with slightly different parameters. So what if fertility was like slightly higher, like if it was like 5% higher, and if it was 5% lower, and then you can get like a range of where the possible values probably lie. And there's another pro that is a bit more hidden, but it accounts for the clustering of mortality. And what this means is that, so we know that in any given population, mortality is not evenly distributed, right? So there are always this, or like empirically, we usually find these clusters of mortality where, for example, certain families are more likely to experience deaths than others. Or like for any given person, the probability that a person loses multiple siblings can be higher in some families than others. And there are like multiple reasons for this. One is that there exist correlations, intergenerational correlations in demographic rates. And like some of them are due to shared environment. Some of them are due to genetics. Like maybe if you were born in a household that is very poor, then it's very likely that your children are also going to be born in that household, but also like your siblings and maybe your cousins share the same environment. So what you end up are these pockets of mortality where like there's a small percentage of the population that has very high mortality, and a larger part of the population where mortality is not so large. And that's very difficult to model. But in these cases, you have these kinship networks, this genealogy that you can use, this population that you can actually, where you can actually look at this. And there are ways of including these correlations, for example, in your simulation. So does anyone, so I think there are like some interesting points that you've made. I'm already like pointing at people to say things, but so there are interesting points about migration, about fertility, about like how much we are actually predetermining the outcomes of our model because we are the ones that create the simulation. So I don't know if anyone wants to add something on any of those points. Okay, so I'm just going to address some of the comments that were already written. So uncertainty we've spoken about. So the other thing is the ability to complement existing data that Marilena wrote in the chat. I think this is an idea that also links to what we've been speaking in previous days about how maybe microsimulation can be also very powerful when used together with other sources. So like maybe we can observe a phenomenon up to a certain point in time, but then we cannot anymore. And then like bringing these two together can help our study both because then we get to check the results, the accuracy of our results, and then we can project into the future. Okay, but maybe we've said everything there is to say about this study. So we're going to move to the next study about the kinlessness study. So Marilena, do you want to get us started?
Sure. I thought the article was very interesting, particularly in the way of addressing late life loneliness. And I think that some of the strengths are, besides the general ones that we mentioned before for microsimulations, also the fact that they use two measures of kinlessness, and also that they look at both projections and some mechanisms to explain the results. As for weaknesses, again, the more general ones of microsimulations that we discussed, but more specific maybe would be that, I mean, still general, maybe based on oversimplification, something that Sasha said before, that they don't look at international migration, and perhaps it would be useful to do it. And again, things that have been said, to look at, maybe it's good to have more simulations and to see confidence intervals and things like this. And I think that's about it.
Mm-hmm. Great, thank you. Do you want to add something, Chi?
Yes. I basically read this paper. It's a very good paper. But also, but in general, I think this paper summarizes the mechanisms like fertility, mortality, and marriage on the kinship structure. But to me, I think this is kind of, we already know this, but I don't know how this works. And this paper addressed this question very well. But I also have one question about the method that they used. They used the population data, and they applied the population data into the individual level. Actually, I don't know how they can use this, because we know the individual have their own characters, their own fertility or mortality of marriage schedule. So that's my question. Another thing is this paper also addressed this basic demographic captures on kinship. But I also think if the kinship structure changed, how this impact the mortality or fertility or the other demographic behaviors, and these behaviors will also tailor the kinship structure. So I think it's a process, and this paper didn't address this question also. And that's all. Thank you.
Great, thanks. So maybe just to address the points you made. So the first one, okay, so if I understood you correctly, you're saying that the inputs that the simulation gets are applied to the population, so our population averages basically. But we want to model individual behavior, and there is some. So like in the end, if we average out all the individual behaviors, we get the population average, right? So, but how can we get at this underlying distribution? And basically, what the simulation does is, so if you remember, I showed in the presentation there was like this random number when you run SOCSIM in this case. So if you see the last line, it says like SOCSIM test soup, and then there's a 98994. So this is a seed for a stochastic process that is gonna distribute. So what SOCSIM does is that given an individual agent, there is a queue of events, right? So this individual agent can either, in any given simulation segment, this individual can experience any of these events. And it depends, right? If you are like 5 years old, then you cannot marry, for example. But given certain constraints, like you can experience this type of events. Then SOCSIM looks at what are the demographic rates that apply to this individual at the population level, and then draws from a distribution and assigns the events in a given order. So for each segment, so say each segment has a duration, can be like 1 month or like multiple months. Then for each segment, SOCSIM assigns an event for this agent. So like, I don't want to get too technical, but basically it draws from a distribution that is defined by the population level rates and then assigns. So not all the agents born in the same year exposed to the same rates are going to experience the same events. But the idea is that the aggregate, so if you then take the resulting population and you estimate the demographic rates that were used as an input, you're gonna get similar numbers, right? So this is what I was showing with this other graph, that your output demographic rates should be similar to your input demographic rates, but not because everyone has the same behavior, but because on the whole, they add up to the same. I hope that made sense. Okay, so does anyone want to add something?
Thank you.
Yeah. So the other issue that several of you raised was this issue of migration. Does anyone remember how they address this question of migration? The fact that they don't account for it, what they say about it in the paper?
They say that migration flows are expected to decline and that the stock is not that high and things like this. But still, I think that the counter arguments are not that strong.
Yeah. So they argue that it's so one reason why you would not account for migration is that it is extremely difficult to forecast migration. And in SOCSIM, like I mentioned that you could have this like change in states within the model, but then you need age-specific probabilities. So like you would need age-specific probabilities that someone is going to migrate in 10 years, and that's just very difficult to get this like reliable data. So this is like a limitation of the paper, of course. So some of my observations, so I really like that they look at these demographic dynamics, and so they do, and I don't know if you caught this, it's only it's one sentence I think in the results where they say that their estimates were robust even after accounting for different divorce and marital rate trajectories. Right, so so they did run multiple simulations that had different projections for divorce and marriage rates, and presumably we are only shown like some kind of mean of those. So it's not very clear what exactly we're shown, but they say that they are robust. So like they assure us that it's not only one simulation, but they do in a way account for this heterogeneity. And so they also compare to ground truth in two ways. So one way I showed the graph of where you compare input to output, but the other way in which they do it, and like it's not always possible to do it, but they actually get estimates of, for example, the percentage of the population without biological children. So these two are from simulations, and these come from empirical data sources. Right, so we see that also like the ages are not the same, and probably like some other things, like surveys tend to be limited to the household, and the simulations is not. So actually the simulation doesn't have like a household, like you could include it, but this one doesn't have. But they compare their simulation estimates to empirical estimates for the period that you can observe. But because the whole point of the paper is to show how this is going to evolve in the future. So you can be quite confident that if it worked for the year 2010, it's maybe also going to be okay for the year 2020. So that's like the point that they make. But I think this is very good practice. It's hard to do. So like one con is that if we think of the current situation, so they did not include the pandemic that we are experiencing at the moment. And so how do you think that COVID-19 could affect the estimates that they get of kinlessness? Like which, would it affect the denominator or the enumerator? And like in which ways could it change the outcomes? Okay, so mainly the numerator. So like we have to consider the age-specific fatality rate, which, as we know, is skewed towards older ages. So that could also affect the enumerator because we're focusing on older adults. And I see some people typing some way. Fatality rates skew towards men. That's correct. And then there's also the issue of unequal access to healthcare like insurance, if you're speaking about the US. Right, so probably exacerbates some process, although it's not entirely clear the effect it would have, right? But we see that like failure to account for these shocks in mortality also adds another layer of uncertainty to the model. But it is, of course, not possible to forecast when these things are going to happen. Okay, so we're going to move ahead, and I want to finish at 5.2 because there is a survey that the course evaluation that I would like you to fill in. And I also want to have as a closing discussion, so we have like 8 minutes. So maybe I just want to conclude with some thoughts about so when do I think that we should use real populations, and when should we rely on simulated populations? So the general recommendation is whenever you can use real data, because simulated data is not real, and that is that's main. That can be an issue. But also, if you rely on simulation, then there are several things that you can do to improve the internal validity of the simulations. Which is, so you can calibrate, you can make sure, like run multiple simulations and then compare your inputs and your outputs and make sure that the outputs that you're getting are sensible. You can triangulate with other methods. So I have several examples here of some work that we're doing where we compare simulations to other methods that we're not gonna really cover, but they are in the slides if you want to look at them, and then compare the outcomes to ground truth. All right, so so this is the microsimulation that we saw already of Sweden, and so okay, sorry, there's typos, but I just wanted to go through what went into the simulation. Like, how did we come to this simulated population? So we had initial population. In this case, we had age-specific fertility and mortality rates that came from because this is a very long time series. So we cannot take them from the UN World Population Prospect as the Zimbabwe paper, but we took them from the Human Mortality and Fertility database, and Sweden is of course used because it has this very long time series, and then we also had marriage transition rates and an internal model for the marriage market. So this is one of the key ways in which different simulation packages differ in how what model you choose to represent the way in which people find partners and marry and divorce. So like one very simple question is, do all spouses need to come from existing agents on the population, or is it possible to import agents from outside of the simulation and kind of bring them into the model and have them marry and be also subject to the rates? And different decisions that you make can have an impact on the output. And the other thing is this, I mentioned these other parameters such as the degree to which you inherit your fertility from the fertility of your parents, for example. So I think in Saxon is implemented, like women inherit the fertility from the fertility of their mothers. And we know that there is a correlation in the fertility of siblings, which results from the fact that there are, again, factors that affect people who grow up together, and maybe there's also some genetic components that determines. So like your fertility is not independent from that of your family. That's the point. So I think maybe we're not gonna cover this. But this is an example of methodological triangulation, and let me see if there's a clear. Yeah, so this is an example of methodological two examples of methodological triangulation where you take a result that you get from a simulation using demographic rates, and then you estimate the same thing, not using empirical data, but using the same rates, but a different method. So in this case, we're looking at sandwichness, which is the probability of being sandwiched between having a young child and the parent who is close to death. So a person who has both a young child and the parent who will die within a couple of years, then you have this double care of responsibility because you have to care for both of them. And this we can estimate with a mathematical model, and we can also get from the simulations, and both use demographic rates as input. And so here we see this idea of the uncertainty and the heterogeneity. So the points in the background are estimates from Soxin, and the purple line is our model, and the green line is the Soxin output. So we can see that there's a broad agreement between the two. There's some differences at older ages, but we get this range that comes from this. So like the value is somewhere in that range. The real value is somewhere in that range. Okay, so this is like methodological triangulation. And so before we move to the evaluation, I would just like to say this. This has been my week, and thank you very much for being here and sharing this. I hope that so I know it was a bit difficult sometimes with the online interaction, but I hope that you got something useful out of it. And so I would like to hear also, like I asked you to think if any of the content of the course relates to your interests or your future project ideas. So can you just share write in the chat if you had any thoughts about how any of this content actually relates to what you're doing or what you would like to do in the future. So I'm gonna give you a couple of minutes. Okay, so we see some messages coming in from cohort data derived from the online genealogies. Using some digital platforms for collecting data on refugee populations. Yes. Yeah, so like this is also something that is related to something Andres mentioned yesterday, how we are sometimes, we are constrained by the options that the platforms give us and by the reach and the penetration of the platform. So like if you want to use, for example, Facebook advertisement to reach refugee populations, that you would need a measure for that. And like one way could be like immigrants who from a given country who have arrived to a given country. So I don't want to say, so I was going to say Syria and Turkey, but I don't know if, I don't remember if there are audience estimates for Syria on Facebook. So there are some countries that don't have them. But that could be one way. Yeah, also like writing in different languages and things. Okay, estimating migration can also be used. So Sasha, analyzing migration and mobility among scholars. So this is okay. So you're interested in this. So this is something that several colleagues are working on, led by Samin Aref, using bibliometric large data sources of bibliometric data to track the high-skilled mobility. That's a very interesting process. Okay, so also using, so Luca mentions also using this Facebook data to look at very localized phenomena, such as mortality by pesticides in particular cities. Yeah, so like subnational analysis is definitely something that we could use these sources for. Yeah, so femicide. So we actually so we have a project. I don't know if this is, so Luca mentions having a better account of femicides. So we have a project now with several colleagues at the lab and in other labs at the institute where we are collecting data on disappeared people from Twitter, and with that you can estimate, you can get some estimates of like this population that is normally hidden, and it's mainly young women who are affected by them in Latin America. So that kind of stuff like you can also do. Okay, this is all super interesting. So I hope that you follow up on these ideas, and please feel free to get in touch if you want to discuss any. So as part of the course, there's still office hours today and tomorrow. So please free to reach out to discuss either this or also something related to the assignment. And so maybe before we finish, like you've written things in the chat, if someone else wants to share something. Then please do so. So maybe what I would ask now, Chi, is to stop recording. So that we